Yeah, we'll do a slant asymptote here. Slant asymptote is when the degree of the top is exactly one more than the degree of the bottom. And we're mostly going to look at it where the top is quadratic and the bottom is linear. We're going to mostly do synthetic division here. Okay, so to find the slant asymptote, first of all, know again, it's the degree of the top is one more than the degree of the bottom. You want to do synthetic division. The quotient will be your slant asymptote, and you ignore the remainder. Okay, so remember in synthetic division, drop the 4, I'm going to multiply, I'm going to add, multiply, add. If you recall, your quotient is 4x plus 2, then we have a negative 1 remainder. Well, what I'm going to do is ignore that remainder. There's a reason for that. Again, it's a calculus-based reason. That remainder becomes more and more insignificant as x gets larger. But this is going to be your slant asymptote. Okay, so I'm going to take this problem, and we'll do 2 if we have time, and I want to go ahead and graph this. Okay, so kind of show you what it is. So our vertical asymptote here, so that's what we call the slant asymptote. And again, to repeat myself, it's different than a horizontal. We said earlier for horizontal that if the top is bigger than the bottom in terms of degree, then there is no horizontal. Well, if it's exactly one more, then there's a slant. And you do synthetic division or division, long division would work too. And you take your quotient and you ignore your remainder. Okay. Now, my vertical asymptote, if you recall, is when the bottom equals 0. So my vertical asymptote, put it over here, is x equals 2. It's my vertical asymptote. Right? So what I want to do here is graph those two lines. It's a good chance to practice graphing. Try to find a clean graph here that's not too badly written on. Again, my slant is y equals 4x plus 2. My vertical, x equals 2. So vertical is a little easier. I'm going to go over to simply make a vertical line. My slant is 4x plus 2. So I'm going to go up 2, put a dot, and then go up 4 over 1. I'm going to do the same thing this way. I'm going to go down 4 over 1. Again, how to graph a y equals mx plus b, you go to the y-intercept, which is here, up 4 over 1, down 4 over 1. I'm going to connect. All right, so what that allows us to do is kind of see where this graph is, and we're going to use Desmos again to actually graph it. To graph it by hand, you would make some points. I'm going to put those same two, be a Desmos screen here. I'm going to put those same two asymptotes, y equals 4x plus 2, and x equals 2. So I've got these. We can see that the graph is going to be fit along that blue and red line somehow. I'm going to type the original equation that we had, or the function rather, 4x squared minus 6x minus 5. And then we're going to divide that by x minus 2. here, x minus 2. You can see that the graph does, in fact, if I zoom out, it hugs those lines. Okay, it happens to be on the left and the right. If I zoom in a little bit, you can see that, how it does. It's very, very close to that red line, very, very close to that blue line on both sides. If I go back to my picture here, it's doing something like this. It's coming down. It's close to that line. It kind of comes out a little bit and then goes back to the line. So it's curved in there. Same thing here. It's really close to the line. It starts to diverge a little bit. It's a little bit harder to see here. This is a kind of a steep slant asymptote. It would be a little bit easier to see if mine wasn't so steep. So let's do one more example to where it's not so steep, because that's not a great picture. So let's do one. We'll do one. The slope of 1 would be easier to see. So again, we're finding our slant asymptote. So something like y equals x squared minus x minus 2. And that does factor, but I'm going to make this be x plus 3 so that it won't cancel anywhere. So the vertical asymptote, just from before, is x equals -3. So the bottom equals 0 after you've canceled. The slant, since our top degree is 1 more than the bottom degree, I'm going to do synthetic division. Okay. So my slant asymptote is y equals x minus 4. Remember, we'll ignore my remainder here when I do that. So that's my slant. So I'm going to take this and try to draw a picture. X equals -3 and y equals x minus 4. Okay. X equals -3. Y equals x plus 4. A little bit easier to see. There's y equals x equals -3. Up 4 and then up 1 over 1. And this is a much less steep line. So hopefully it'll make for an easier or nicer looking picture. Okay, so we have this. Again, we're going to go into Desmos here. So x equals -3 and y equals x plus 4. We're home. So there's that same picture, the purple and the black there. If I graph my function here, squared minus x minus 2 divided by x plus 3. And that does not look right, does it? At all. Oh, that's because I typed in y equals x plus 4. Excuse me. I copied it wrong. This is my problem. All right, so now, yeah, so now you see how good that looks. So going back to my graph, that's a -4. So I should have went down here and graphed it like that. Okay. And you can see again the graph on here that comes in real close and it bends back like that. Does the same thing down here. Okay. So that's slant asymptotes.